Good morning, everyone, or afternoon, or evening, as the case may be. And thank you for joining us today for the first webinar sponsored by the Microfade Testing International Discussion Group, where we'll be discussing the 3 models of microfade tester currently in common use. I'm the group's programming chair, Cindy Conley-Ryan, and I'll be co-moderating this with our chair, Vincent Beltran. We'll have 3 speakers, each of whom will be discussing one of the 3 models of microfade tester that's in most common use. Then we'll have a short panel discussion with all of our presenters, followed by an open Q&A. So as you're thinking of questions, just drop them right into the Q&A link at the bottom of the Zoom screen. Next slide, please. And actually, I think I've already introduced us, so go right ahead to the next slide. I like to start by thanking people, and we would collectively like to thank AIC and the Preventive Care Network for agreeing to sponsor our discussion group as an online community, and to thank the Getty, who's providing the IT backbone for today's event. Next. Next, again, I'll just start with a few words about microfading in general and the discussion group in particular. I suspect you all know this already, but I'll be brief. In brief, microfade testing is a technique that was developed and introduced to the cultural heritage field in the late 1990s by Paul Whitmore, who you see here with what looks like the 2nd or 3rd gen iteration of his microfade testing system at Yale University. And this technique directly measures the light sensitivity of a material in situ on the object, rather than doing predictive testing with models and mock-ups, directly measuring a vanishingly small spot for a short period of time with high intensity light to give you predictive data about your object. Next slide. The basic scheme of the instrument, although there are many iterations, is a light source of whatever type that delivers light, usually through an optical fiber, to the surface of an object. Then reflected light is collected at some angle or another and delivered through another optical fiber to a spectrometer that then talks to a data management system that translates those reflected spectra into chromaticity and color space change data. If this is all new to you, I encourage you to look at the video that we have a QR code here for, and we'll drop that link into the chat for you. It's a brief general introduction to microfade testing, very accessible for broad audiences. Next slide. So what this technique gives you is information that can inform decisions about exhibit lighting for any sort of object in cultural heritage, any surface, any texture, any substrate, dyes, paints, pigments, you name it. This is the rare example of an analytical technique that has emerged completely from within the conservation field. And in the decades that it's been in use, a number of alternative setups and iterations of the instrumentation have been evolved from that original Whitmore design, changing either the light source, the measurement geometry, aiming to make things more portable, easier to use, semi-automated, contact probes, but all following the same basic principles of operation. Next, please. This map is slightly out of date, but this gives you a sense for where these instruments are in use. There are roughly 100 instruments now in use worldwide, spread out, large concentrations in Europe and in North America, but with some representations spreading into the Middle East, the Far East, and Eurasia. So we're a pretty small community for one particular instrument. There aren't hundreds and hundreds of other users in other fields using this technique, and we're pretty spread out. And as long as I've been doing MFT, which is since 2007, there's been an urge from the people using this technique to have a better way of communicating with each other, because we've all learned from whoever got to there before us. We've all learned from each other within this community. And hence the creation of this discussion group. Next slide, please. It's launched at the beginning of this year. It's an open forum. It's sponsored by the American Institute for Conservation, but you don't have to be an AIC member to join the online community. There's a link here again, which we'll drop into the chat, where you can go to our landing page, check us out, and join the community. The goal of this group is to be a platform and a venue to ask each other questions, to learn from each other, to share resources, and try to support and advance the practice of microfading technique, and be a place for discussion about both how to do it and how to use the information you gain from it. Next, please. We're still getting started. but we have gotten a few things done already in our first year of existence as a group. We've greatly expanded the AIC's wiki page on microfading technology. We sponsored a conference session at this year's AIC annual meeting, and there'll be another one at next year's AIC Canadian Association for Conservation joint meeting. We have a couple of training workshops in the works, and we're hoping to have several more webinars coming up. So that is quite enough from me. And at this point, I'd like to hand it over to our first speakers. Kirsten will be up first, and then JP, and then Abed. So Kirsten, take it away. Why don't you go ahead and share your screen?
Thank you very much. Hi, my name is Kirsten Dunne, and I'm the Senior Projects Conservator at National Galleries of Scotland here in Edinburgh in the UK. I'm a paper conservator by training, but my role now leads on microfading, time-based media conservation, and looking at applications of technology to conservation practice. So I've been working with our Whitmore style MFT since 2012, using it to support risk-based data-driven display decisions for our collection, and also increasingly as a means by which we can reflect on and review wider practice and approaches to collections care and management. So we acquired the MFT, as I said, in 2012. We did this with the guidance and support of Bruce Ford. So my practice and setup are inextricably linked with Bruce. Our current setup is relatively classic. It's consistent with Dr. Whitmore's original design using fibre optics, and we're currently still working actually with a Newport Xenon 75-watt bulb and lamp system, which has served us very well, but we are hoping to upgrade to an LED light source when our budgets allow. Buying the equivalent to our setup nowadays, you're looking at around $16,000 US for an LED setup and about $25,000 for the Xenon version. Again, those figures are from Bruce's website. And both those costs include all the components you need to build the kit. And as I understand it, the sort of software and IT setup as well, and the report templates. So it gives you everything you need to go, and it also includes remote training with Bruce. And I think actually after the initial investment in the equipment, the real investment comes in staff time to build your working knowledge and start to apply microfading to collections care. So the more modern setups do look a bit different to this, but the principles are the same as you saw in Cynthia's slide before. So you've got your light source, and ours is currently still that Newport Xenon bulb. The light is filtered in our setup for ultraviolet and infrared at source. There's a filter system in the front of that box you can see, and that filtered light is then focused down a fibre optic to the measuring head, which sits above the object being tested. And that instant light is focused down through a small lens system into the instant beam, which is about 0.2 to 0.4 of a millimetre in diameter when it reaches the object. The instant light is then reflected from the object, obviously in all directions, but it's picked up at a 45-degree angle by another fibre optic cable, which takes the reflected light to a spectrometer. And then you can then see what that reflectance spectra looks like on a computer screen, which I'll show you shortly. So the complicated part of the assembly for me was really putting the lens system together and collimating the beams. But I believe you now purchase those sort of ready to go, so you don't have to do that. It's just a case of linking it all together. And unlike with our Newport lamp, the newer LED and Ocean Insights lamps require less user alignment or other maintenance. So it's a greatly simplified setup and use. We have an XY travel system, which is just very basic, as you can see in the image, but it's worked well for us so far. It just G-clamps to the balance bench that we work on. There are much more elegant systems than this, but the point is you need something to safely move the measuring head around your object. This is an image that Bruce sent me of a more contemporary LED setup, and hopefully you can just see the similarities between what I'm using and this, so not much different. Slightly more elegant, maybe. The front arm of the measuring head rotates, so you can test two-dimensional items on a surface below, or you can test three-dimensional items. And this is a non-contact setup. So the lower edge of the measuring head sits about 1 centimetre above the object surface throughout. I just wanted to show you how it fits into my studio space. I've got this sort of L-shaped bench set up with the microfader, a space with a table I can move about for the object to sit on, and also my laptop and computer screen that I run it from. And I really like having a second screen because you can watch a test run live whilst you're doing data management on the previous run. So I think Bruce now 3D prints this part. This is what I'd call the measuring head. And this is what sits above the object being tested. So you've got your instant beam coming vertically down there through the center. You've got your pickup beam at 45 degrees. And I've also got a USB camera, which allows me to see exactly where I'm testing and then record that test site as well. This is what the inside of the xenon light looks like, and I'm showing you because sometimes you need to change that bulb. So the bulb does create some heat, and there is a fan in the box, so it does create some noise. But again, I suspect this is much improved with modern iterations. And I just also wanted to show you where that internal filter holder was for the UV and IR filtering as well. So one of the more slightly fiddly elements of this Newport setup is that sometimes you just need to reposition that exit cable in front of the light, and it can be a little bit fiddly. But with the LED version, apparently it's much more easily done with a small Allen key. So again, modern iterations, much better. So in terms of training, I actually had a couple of weeks training with Bruce, but this was 13 years ago, and he's streamlined that now, so I think it's more like days than weeks. What I really valued in the training was time spent taking apart and rebuilding the kit. That allowed me to really get to grips with the different parts and how they fit together, and has really benefited me for the few issues that we have had. I've had to troubleshoot because I understand, I can trace it all back and understand what does what. After the training as well, we committed to me doing a set amount of testing per month. And that was really valuable to me to have that time set aside in my diary just to make sure I was practicing and embedding my practice. So the training went through the build, the setup. It covered what I needed to know about the spectrometer software and running test runs, doing all the calibration and setup, and also writing the reports. At the moment, I'm the only trained user within our organisation, and that's largely because we're quite a small department, but we would really like to change that. And I'm looking to hopefully train colleagues, very possibly with Bruce involved remotely, probably when we switch to our new LED model. It is a portable bit of kit. Ours fits mostly into a large suitcase, accompanied by a laptop and a laptop bag and a G-clamp in a box. The key thing is to have a stable surface to work on wherever you're transporting it to. And I have to say that in most cases, that's the most difficult part of using the microfader in a portable manner, and is quite often why people end up bringing the objects to me to test, because I'm very fortunate that my studio is on a ground floor and has a concrete floor and a very stable surface to work on. So I mentioned I've got a balance bench. This is what I mean by a balance bench. So if you get vibrations running through the setup when you're taking readings, it can affect your readings. It almost sort of fakes a fade, as it were. So it's important to have a stable surface to be working on. So this is our balance bench, and it's got these lovely cork pads at the corner which absorb any vibrations that do manage to come up through the floor. As I've alluded to, the maintenance required on my setup is quite minimal. Now and again, you need to change the bulb, and you can generally tell when the lux output is dropping off, and you might need to do that. And that's probably at maximum about once a year, but obviously that depends on use levels. It can be once every 2 years, really. Obviously, it's just about keeping an eye on the readings that you're getting, and once you've got a bit of experience, you can often tell they're not quite making sense, and you might need to rebalance the lamp or look at bulb replacement. And sometimes it's just a case that the cables need retightening, so a nice bit of maintenance is just to regularly retighten cables. Once you've got the equipment built and up and running, next step is obviously using it. As part of a day of testing, and I do tend to plan to test for a whole day at a time or a couple of days, just to make best use of time. I'd switch on the lamp first thing and allow it about an hour to warm up, because the xenon lamps need that to stabilize. I undertake a software setup and calibration. So as part of that, I do a daily white balance. And that's just telling the spectrometer software what 100% white looks like. I also give it an ambient reading so it understands what the background light looks like. And that's just all me setting up the software. And then also run blue wall calibration run. So I'm using blue walls as my calibration. I still use blue walls 1 to 4, but actually only really need to use 1 to 3. I'm just going to the habit of using 1 to 4. But this is all just part of me sense checking the bulb and make sure everything's functioning the way it should be. This setup uses a manual focus, which I'm quite happy with. It's a case of just moving that measuring head up and down using a turn knob on the side to get the maximum reflectance from your test site. I currently also have a manual shutter to start and end test runs, but I believe on the LED setup, you can have a switch on the lamp so you can operate and do that remotely. I wanted to give you a sense of what the data looks like when you're looking at the screen. So I use Spec32 software, which is the spectrometer software that came with our setup. During test runs, I'm watching the reflectance spectra within the visible light spectrum. So I look at 400 to 700 nanometers, but I think you can see slightly wider than this. Crucially, I'm watching that rate of change, the delta E, and not allowing that to get anywhere near a specific figure, which is a value of 5, because this software works in CIE 76. And that's when you're potentially getting into the realm of the change you're inducing in the test site being visible. And obviously that's not what we want. So I'm using the spectrometer software to gather the data, and it comes in DAT files, which I then put into Excel to do all data management. My fade runs are 10-minute long. I take a reading every minute during those 10 minutes, but I can obviously alter that using the software setup, so I can take them more or less frequently and change the duration of the overall fade run as well. 10 minutes is sort of a nice balance. It's a good amount of time to get data, a decent amount of information to support risk-based decisions. But it's also time efficient in terms of running multiple tests per day. Like I mentioned, when I'm doing a fade test run, I'm often doing data assessment on the previous run and starting to write the report. So overall, it's quite a time efficient process. I'm often testing objects driven by display requests, but also from colleague concerns. So once an object comes to my lab for testing, I'll have a look at it under a good light source and decide how many colours I can see. So it's a visual process that's obviously subjective. So I often do that with colleagues, and we write a list, decide exactly where I'm going to test, and then set up the object underneath the microfader. You do need to make sure that your support doesn't move during a test run. So you need to think about how you're going to do that, whether you can locally weight your object. You might support something from behind, because again, that's a form of vibration. If support moves during a test run, it's like a vibration, it can affect your data. But obviously it needs to be okay for your object to be able to weight it locally or whatever you need to do. I create an annotated photograph just using Photoshop to map exactly where I've tested on each object, and that's part of the report system as well. So this is an example of the data I gather per test site. So you can see a photomicrograph taken from that USB camera I showed you. So that shows you exactly where I'm testing. So you can see a signature I was testing there in that bright white dot. That is not a faded spot. That is the instant light cut to 10%. So I can record exactly where I'm going to be testing. I then get data from LAB colour space, look at how the colour coordinates might have changed. And I also get the start and end reflectance spectra for that particular test site. And this is what goes into the report. So I do create data per test sites, which is really useful in understanding the details. But I also create this table of information for the object overall, which is part of formulating that overall light budget recommendation for display management. So the table lists all the test sites and the blue walls. I've got all sorts of information in here in terms of sort of, change in LAB values, chroma and hue, which are nice additions, I think. But what I'm really interested in is the blue wall equivalents. That's what I use to define our light budget and recommendations, usually based on finding the most light sensitive area in the object that I've tested. So Bruce set up all sorts of macros, which he shares with you, and this helps me create all of these sort of graphs and visuals quite quickly. I love tabulated data, but it's also quite nice to put it into graphs for those of us that see things visually. So this is just a graphic representation of the blue wall equivalents. and the results. And again, here you can see the ink is the issue, although that might be misleading because it might be Angor ink. So you do always need to think about your results and contextualize them. This is another graph I create, color fading curves. They can be quite interesting in themselves. You've got time elapsed and rate of change, and you often quite classically see initial quite rapid rate of change and then things tapering off. And I bring all this together into a report, which has all the charts and everything else you've just seen in the later pages, and then a front page, which summarizes the findings. And this is what gives the recommended light budget based on our light guidance table. So it's great getting all this really detailed information. You can do all sorts of things with it. But for me, it all makes sense when you have a light budget guidance for your organization. That means you can apply what you found to collection management. I think specific light budget guidance is a webinar in its own right, so I'm not going to show you that today, but the approach we've been using is based on the work that Bruce Ford and Nikki Smith published on lighting guidance developed for the National Museum of Australia. I also look at the known exposure history of our object and compare that to our recommended light budget to give indications when we may need to be concerned about objects display, and conversely, quite often when we need to be less concerned than we are. Currently, we're working on a baseline assumption of 500 years as an acceptable lifespan for our collection, and that's built into all of our guidance. But that was only ever a starting point for a number, and it's something that we're currently discussing and reviewing, which I hope to be talking about more soon. So just finishing up by giving you a couple of examples of how we've used microfading data to give some helpful and pragmatic display decisions. So these two works on the screen, in both cases, the signature was the most light sensitive area found and was going to drastically restrict display when both of these objects were under high demand for display. So you've got a pastel by Degas at the top there, and the signature was actually on the woman's foot, so quite far into the image, and you couldn't cover it over easily. However, on discussion with curatorial colleagues, we decided that actually we were okay accepting potential colour change in this signature, because as it turns out, it was non-original. It was added by the artist's studio at a later date. So they were willing to accept potential change in the colour of that signature to facilitate display. With the Paul Klee prints, the signature and inscription was a very important part of his cataloguing system. We didn't want to affect or lose that. However, fortunately, this was at the bottom of the image, so we could cover it with a window mat for display. So in both cases, microfading data indicated to us what the issues were, and we were able to work collectively to find pragmatic solutions which kept the works actively displayed. And that is me. Thank you very much. I'm now going to hand over to JP, who's going to talk about his retroreflective unit. Thanks.
All right, thanks very much, Kirsten. So I am JP Brown. I'm going to be talking about the Jacob Thomas designed retroreflective MFT unit. We built one of them back in 2020. During COVID, and we've been using it pretty much continuously ever since. We use it to assess the light sensitivity of collection items going on the display or on loan. And I just want to mention that the Field Museum has a pretty small conservation department. We have 3 permanent conservators and up to 3 contract conservators. So MFT is not just for big institutions. The standard parts list for the Thomas retroreflective unit looks something like this. The source is a Mitex LED, which is actively cooled, super stable, warms up in about 10 minutes, can run all day without power variation, no UV, no IR, about $3,000. Usually the spectrometer is a Broadcom Q Mini wide Viz for about $2,100, but you can basically use any spectrometer. Broadcom, Ocean Optics, and CDI are all supported by Spectral Viewer, which we'll get into later. Most of the optical components come straight from Thorlabs. It's about $1,800, including a 30mm and a 50mm 4-lens, so you can choose your spot size and working distance. And that also includes all the tools that you need to assemble the unit. The optical power sensor, which you're definitely going to want, is about $750, and then your spectral on white reference is $530. And if you need something to support the whole unit on the end of a microscope boom arm, that's about another $250. So you're looking at $8,500 to get started, and then possibly another $1,100 for optional stuff that we'll talk about later. Just to clarify the optical design, light comes in from the supply fiber and passes through a beam splitter. The collimator parallelizes the beam. The fore-lens concentrates the light at the spot. Some of the light is reflected back up the light path and is reflected by the beam splitter into the return fiber and hence to the spectrometer. The unit is generally used in a 15-15 geometry to give a reasonably powerful spot, but there's no reason why you can't run it at 45-45 if you're prepared to lose about 25% of the spot power and deal with a more elliptical spot shape. All the parts you saw in the previous two slides go together in about an afternoon. Once you've made the unit, you're basically done. I find that I can now do it in about 90 minutes, but the first time it was definitely a full afternoon. The good news is that all this is reasonably inexpensive and you can modify it however you like, and the results are great. The bad news, of course, is that fixing it is on you. Operationally, the basic Thomas unit starts taking spectra at 1 second intervals with a physical shutter material, in this case aluminum foil, over the sample. The foil is removed to expose the sample and begin the measurement series, and spectra acquired prior to removing the foil are discarded. Just as a side note, if you are using a foil shutter, we found that the Roscoe Cine foil is much easier to handle than the regular stuff. So you set up your light source and spectrometer, focus on the measurement site with the micrometer, and then interpose some sort of opaque material, like aluminum foil, to block the light beam from hitting the surface. When you're ready to take a measurement, you remove the shutter and start taking spectra. For data acquisition, you've got whatever your spectrometer maker provides. So controlled development spectrometers would be using CDI Spec 32. For ocean optics, it would be Ocean View, or for Broadcom spectrometers, like the one we use, it would be Waves. And then you're going to do some Excel magic to convert the spectra into color change values and compare them to blue wall standards 1, 2, and 3, faded on the same machine to determine your equivalent fading rate. However, what I find is that working on 3D social history items at the Field Museum, the aluminum foil shutter was difficult to use when the surface being measured was not horizontal. And basically the shutter would just keep falling off. So we moved to a system like this. It's a flip-out holder with 2 filters sandwiched between 30mm cage plates. The assembly sits in the collimated portion of the beam, so moving the filter in the assembly in and out of the beam has a negligible effect on the overall light path. We use a 715 nanometer low-pass filter, which produces a dim red spot, paired with a 0.7 neutral density filter to further reduce the spot intensity. So when the shutter is in the closed position, the head projects a low intensity red dot, which we use for positioning the spot accurately and for focusing. In this earlier version, we were using a finger actuated movement. So you were sort of flicking the filter in and out of place, and we didn't love that. So the current iteration uses a camera release cable to lock the shutter open, and then there's a small spring that makes sure the shutter goes back into place when the cable is released. Because you can modify the Thomas unit pretty easily, the other things we've added are a cheap and cheerful USB microscope, that's about $70, and a 15-degree angle guide. So when we're working on 3D stuff, we can make sure we're approximately correctly aligned. The microscope allows you to locate the spot in the correct point of interest, and Microsoft Camera, which comes free with Windows 11, is perfect for this kind of live viewing. So that gives us a control scheme like this. Then we wanted to have control over the LED driver. Now, you can set all 4 channels manually for focusing and exposure, but it's a real pain to get all exactly the same each time. And since Mitex distributes a free software kit, we wrote some software to use it to talk to the driver. So now we can turn the spot all the way off quickly if we need to, or turn all the channels to their preset maxima when it's time for an exposure. We find that the Mitex source is robust and super stable, no significant variation over 15 hours of continuous use, which is exactly what you want. Now, once you've got the light source under control, you're also going to want to characterize your spectrometer. And it appears, I've got to say, that the Q Mini is not stable at high operating temperatures. We ran into some issues with white reference stability when the spectrometer was running warm, so in the upper 30s degrees Celsius. And shifts in L values in that previous graph were probably a consequence of arranging the light source and spectrometer as shown in this image. The spectrometer is lying flat on the table at the left of the Mitex LED source. Now, as I said, the source is actively cooled, which is great for stability, but the cooling fan sucks air in through the top of the controller, and the warmed air is blown out through holes on the sides. So if equipment is arranged like this, the effect is to increase the temperature of the spectrometer. So we 3D printed a small plastic clip with arms, fitted some magnets into the bottom of the arms, so that we can adhere it to the steel grill that covers the light source fan intake. So you're sucking cool air over it the whole time. And moving the spectrometer to this position seems to have solved the stability problem and keeps the spectrometer temperature stable at about 26 to 28 degrees Celsius. In use at the Field Museum with our currently modified version, the whole thing looks something like this, mounted on a binocular microscope boom arm. However, given our 1515 geometry for 2D collection items like this, we more typically set the MFT unit up on a 15-degree stand, which is sitting on a beveled 1/8 inch thick piece of borosilicate glass. And the glass acts to flatten textile fibers and, together with the stand, makes readings more reproducible. Now, this sort of approach is super useful for fluffy materials such as textiles and fur, but can basically be used with any 2D material that can tolerate the weight. It's also super useful for getting readings from colors in the middle of very large 2D items like quilts. Now, finally, unless you really love Excel macros, you're going to want some software to do the color shift calculations. Most spectrometer software doesn't actually provide this functionality. It's kind of a niche thing. But fortunately, back in 2008, Lionel Keane at the Getty whipped up a little program called Getty Conservation Institute Spectral Viewer 2, which we've been updating ever since COVID in collaboration with Vincent and a bunch of alpha and beta testers that Vincent organized from the MFT expert users group. So the final operational setup as we use it at the moment looks something like this. And in use at the Field Museum, our modified version used in collections looks something like this. We could make it significantly more mobile by using a laptop computer, but a desktop definitely gives you much better quality of life when you're doing long measurement days. So how portable is this system? Well, I haven't actually tried packing it to go off-site yet. But I'm pretty confident that everything fits in a standard carry-on size Pelican case. What about maintenance? Well, we don't do any routine maintenance. We do keep a detailed user log, which you see here, which allows us to diagnose issues. Sometimes it's the user, sometimes it's the equipment. Entering data in the user log during setup at the beginning of each measurement day is basically our main thing, which brings me to how we actually use it. So at the beginning of the day, we check and log operation. We transfer the MFT to an optical test bench, which is included in that $1,100 of extras that I mentioned at the beginning. Check the spectrometer, check the light source, check the power level. That's what the power meter is for. Take a dark reference, set the white reference, check that we're getting the illuminance value that we expect. Close the shutter and then transfer the MFT to a stand. So that takes about 20 minutes once you've got good at it. And then to take a reading, you make sure the shutter is closed, select your feature of interest, create a survey in Spectral Viewer, Focus on the red dot integral maximization. So we're looking at the spectrometer signature to get the most power from our dot. Start the spectrometer acquiring spectra, open the shutter, and monitor color change. Now, here's the bit that's peculiar to us. If the color change is below blue wall 3 after 2 minutes, we just stop because we're basically not getting any useful information. If the color change is greater than delta E 2000 1.7, we terminate the series because you're starting to move into an area where the dot would become detectable if you continue. And otherwise, we continue until 8 minutes have elapsed. We capture 2 series for each color of interest, and we'll do another one if the first 2 are significantly different, and then we'll take the 2 which agree most closely. Then you move on to the next color of interest. In Spectral Viewer, you can watch the spectra arrive in real time, just after the spectrometer writes them to disk. So once you've unshuttered and got a few spectra, you can nominate the starting spectrum, the one immediately after you unshuttered, and switch to the delta E 2000 screen and watch delta E 2000 change in real time. There are audible and visual alarms if the levels go outside your designated limits for delta E or your acquisition time. This is helpful because, as Kirsten said, you're generally multitasking, working on some stuff that you already acquired while the current series is being acquired. And you can show the data from any of the other previous surveys to compare with your current acquisition, or you can turn them off to concentrate on the current series. After you've acquired all your data, you set the initial spectrum, the last spectrum that you want to import, the desired time interval between spectra, and then click the transfer button, and the data are pulled into the main spectral viewer display. Then you go on adding series and surveys until you've got all your data. So once you've got all your data, what do you do with it? Let's consider the case of these moccasins. Here's the MFT data from the buckskin, textile, and dyed porcupine quill as displayed by Spectral Viewer. Now, Spectral Viewer can inject the data for each color into an Excel spreadsheet to create special charts and then save the Excel workbook as a PDF for archiving. That all happens automatically when you press the export data function. And I should mention here that the Excel templates that we're using are derived from Jacob Thomas's workbooks for MFT analysis. So just to see what that looks like, let's take the example of the survey for the yellow quill shown here. The PDF starts with a summary of the test, displays a shift in CLAB variables over the period of the test as a chart and in CLAB space. And you can see here that the yellow color is desaturating. And Spectral Viewer extrapolates the test data using spaghetti fitting to make predictions about fading beyond the period of the test. Then the data, together with the extrapolation, is presented as a heat map, which shows the predicted delta E 2000 color changes. Now, this heat map is what we usually share with people when we're discussing restricting exposure for a particular collection item. So training, we've got 1 expert user, me, 2 other reasonably regular users who can work on their own, and then 3 or more occasional users, contractors or interns. So training is one-on-one. Training someone to use the system competently takes about half a day. That doesn't mean they can figure out all the problems that they might have, but they can certainly operate it and get usable results. People who've not used the system for more than about 6 months usually need some help with initial setup and about half an hour of supervision, so something like 1 full survey in the next series before they're running the system comfortably again. So that's all I've got to contribute on this. Thank you very much for your attention. If you have any questions or issues, pop a question in the Q&A, post on the MFT-IDG list on the AIC website, or feel free to email me, jpbrown@fieldmuseum.org. And now I'll hand over to Abed to talk about the Fotonowy setup that they've got at the moment.
Again, thank you everyone for being here. My name is Abed Haddad, and I am an assistant conservation scientist at the Museum of Modern Art in New York. And I will be speaking to you today about the Fotonowy MFT, which is kind of the newest kid on the block in terms of microfade testers. So just to give you a little background, I started my experience using MFT in 2017 when I was a PhD student working with Kirsten and Anna Martins at MoMA. And at the time, what we used was a contact style modified Whitmore design. So with the traditional Whitmore design, you have a non-contact setup, whereas Chris McGlinchey worked to modify the Whitmore style by introducing a bifurcated fiber optic cable to allow for contact on the object, which eliminated some of the focusing issues that could take place with a regular Whitmore style. However, the contact was prone to a lot of vibration, which made sometimes collection a little treacherous, making sure no one walked by or bumped the table as you're collecting the data. And sometimes contact was not appropriate for certain materials, for example, friable pastels or textiles, not because they couldn't withstand the contact, but because the pressure would alter the working distance. So you perhaps were not collecting the most reproducible data. But we use it a lot. It was a favorite instrument. It was something that informed a lot of exhibition design and exhibition strategies. And it was a great teaching tool that we also used for graduate interns, as well as fellows, etc. However, in 2019, we realized that our spectrometer was not collecting data appropriately or correctly, and it was drifting quite a bit. So we decided to investigate a new setup. We've had the contact Whitmore for quite a bit of time at that moment. So we wanted to look at something different. So we had a couple of options. The first option was to get a brand new, Whitmore design and kind of moving away from the contact setup into traditional Whitmore design. But we realized that there was something new, and that was the Fotonowy MFT. And so we ended up going with the Fotonowy, and there's a couple of reasons for that. So you can see me here on the floor with the Fotonowy with a rosemary truckle textile. And one of the first reasons we really liked it was really easy to use. And quite often, conservators alongside scientists at the museum collect the data. So we wanted something that was really plug and play, simple to use, and could be something that we instruct a conservator on how to use, and then they could collect the data. But another thing that we really liked was that it used an LED light source in comparison with xenon arc light source. Xenon arc tends to have a much broader spectral distribution, but we had switched all of our lighting in our galleries to LED with the 2019 expansion that we had at the museum. So we were interested in using a light source that was as close as possible to the lighting that we have in the galleries. Most often the question we have for us at the museum is not if something can go in a window, but quite often if something can go up at all, or how light sensitive it might be to gallery lighting conditions in particular. So we wanted to kind of mimic that lighting environment as much as possible with our MFT measurements. So just to take a look at how much it costs to get a Fotonowy instrument, it is on the more expensive side in comparison with the other instrumentations. So for us, the microfade tester at the time comes with a transport suitcase, a spot camera, a tripod adapter, and what they call an extension arm, which is a second kind of block that extends the measuring head a little bit past the base. And that costs around $30,000. You need to get also a light calibrator, which acts as a radiometer to auto-calibrate the LED light source so you can get accurate measurements in terms of photometric and radiometric units. You also want a white standard. You can already have a white standard if you're just upgrading your setup, or you can get one from Fotonowy. The online training, so I can't speak to having an in-person training because we bought this instrument right around the pandemic. And so everything was kind of done remotely. So we did have an online training session with Professor Thomas Lajowski. And shipping, I'm assuming it's going to be dependent on where you're getting the shipping from, or shipping to, sorry. However, what was nice about it is that we could get a little bit of a discount. So if you paid 80% in advance, you could get a 5% discount, which 5% of 30,000 is not a small chunk of change. So we did go with that option, and we had a warranty for 12 months. Delivery time was about 8 to 9 weeks, and as I said, we purchased it during the pandemic, so we had to do everything kind of online. So this is kind of what you can see with the MFT setup with the Fotonowy. So you can see that there are several parts here. You can see first that the spectrometer is mounted to the back of the motorized tower. What's really nice about it is that you can control the distance between the object by doing using the software instead of having to do it manually. So you can just use the software to move the head up and down. So the spectrometer is connected to a fiber optic cable that goes to the measurement head. This is what I was talking about with the extension arm. So you can see that there's a kind of a small block here that extends the measure head past the base plate. And then the LED assembly is going to be located right above the measurement head. And that gives you a 0.45 optic setup. And if you look a little more closely at the setup, you can see again that there is a 0.45 optical setup. So the LED comes, the light source comes directly above the sample. And as we can see the orange arrow, and then it's collected back at a 45-degree angle. And as I was mentioning with the LEDs, there are different LED sources that you can choose from in collaboration with Fotonowy, depending on the correlated color temperature and the spectral distribution that you're interested in. There are different options on how you might integrate different LEDs into your setup. You can choose to have one static LED, and this is kind of what we went with. While we do research at the museum, the main interest with the Fotonowy instrument and having MFT at MoMA was always exhibition driven. And so for us, having one light source was sufficient. However, you can get a carousel that has different LEDs in it. And you can also get monochromatic LEDs if you're interested in studying wavelength dependent color change, or you can get sources that are UV or near infrared if you're again looking to investigate specific response to different wavelengths of light. But if you are interested in specifically exhibition parameters, what I would suggest is matching the LED as close as possible to your color, correlated color temperature in the galleries and the spectral distribution to try and get as much of a one-to-one comparison between the MFT data and your real life color change. You also need to purchase a light calibrator. So this is kind of a radiometer that they sell. And the radiometer, it can be used for different instrumentation that Fotonowy makes, but you can use it for the microfader. What you do is you focus a spot of light on the calibration head, and you click an auto calibration setup on the software, which is really nice. And what that does is allows for an easy calculation of the radiometric and photometric QTIS, and I'll talk a little bit more about that later in the maintenance section. I would say, unlike the other two setups, it is really easy to take this instrument apart and put it into a carrying case. So as you can see right here, the carrying case is kind of a regular Pelican case size suitcase. And it comes with a cutout foam where you can put all of the different parts. And we do take the instrument often to our storage facility, which is across the river in Queens. We are based in Manhattan. And we can do our analysis for objects that are either too large to bring to our Manhattan campus, or we can take the opportunity to do something and understand its behavior to light before we actually bring it on site if it's never going to get shown anyways. So you can see the base plate goes on the bottom, and then the fiber optic can be just put in a small bag and protected under the base plate, which I kind of like that design as well because the base plate is quite sturdy. So I made a little stop motion animation, I guess, so a little video. You can see me putting together the MFT. I didn't realize I'm wearing the same sweater that I'm wearing right now. But as you can see, it's quite simple to put together. It takes about 5 minutes to dismantle and about 5 minutes to put together. And so I find it to be a really attractive feature of this particular instrument because it allows us to take it to different places and use it on site, be it at storage or sometimes in the galleries. So for training, as I mentioned, we had our training in the pandemic. So Professor Tomasz Lechowski, who works closely with Fotonowy in Poland, he gave me an individual training when we first got the instrument. So that meant putting the instrument together, coming up with the measurement parameters, and thinking about different ways to utilize the instrument. But at MoMA, the scientists train conservators, fellows, interns, students on the data acquisition, and we do the interpretation together for any kind of exhibition-related information. I will say we also did have a group training session with Professor Lechowski when we also got the instrument. So we got the department together and we just did kind of a demonstration together. So with the experimental setup, what I do also like about the Fotonowy is that you can set it up in a few different ways. So for example, you can see here on the left a Paul Cézanne watercolor. If your object can handle a weight, it's really nice to put on a weight to make sure that your object is as flat as possible. But we built kind of a custom-made base to place the objects on, which kind of extends the area that you can analyze using the Fotonowy MFT. But what's attractive about it as well is that you can kind of turn the instrument all the way around 180 degrees and put a few weights on the back and analyze objects that are way larger than just a watercolor. So you can see here there's a Gaetano Pesce chair. There was an interest in understanding how light sensitive that material is, or the upholstery. And so you can just turn the whole thing around and collect data, which is really nice when you're thinking about doing larger objects. What's also nice about this particular instrument is that you can put it upright on a tripod. And that actually really expanded our use of MFT at the museum. So in the past, quite often we were limited to a certain degree in the size of materials that we could use and the orientation that we could analyze an object in. But being able to put it on a tripod and stabilize it is really helpful. So in terms of how to use the instrument and the daily setup for the instrument, first, it is motorized, which makes it really, really attractive when it comes to autofocusing in particular. And so here you can see the measurement head with the a white reflective source. And the motorized head moves upwards from the focal plane to locate the position of maximum reflected intensity. So you can this is kind of the animation it shows you. You can see at the top it's kind of moving upwards, and then it will reach that maximum intensity, and it will realize that that is where the focal point is. And that is really helpful when we are looking at things that have a lot of different varied morphologies, or can have textured morphologies, something like textiles, for example. And when you look at the setup window, you can see that there are different kinds of parameters that you can control. I think one of the main things you can control is the current. So that helps to come up with different illumination intensities. So you can examine color change at lower settings. The maximum it goes to is 1,000 microamperes, milliamperes. And so for us, we tend to go on the higher end so we can get a speedy answer quite often, again, the question is, can this go up? And sometimes the turnaround time is very short. So we don't have time to do a larger research project most often. So we're just trying to understand if something is light sensitive, bar none. You can also adjust the spectral collection settings. So you can look at different integration times, different sampling periods, which could help with noisier data collection. So for example, if you're getting quite a bit of noise from something that is quite textural, like a woven piece, you can change integration times and the sampling periods to get a better response. What I like in comparison to what we had in the past, I know the new spectral viewer can do it. I do love the new spectral viewer. Is in the past we couldn't end the aging time at a something that was suitable for us. So we had to actually monitor and set an alarm for ourselves at 10 minutes to stop it. So now we can actually set up an end aging when it's at 10 minutes, or this is usually how much we run the samples for. Or you can run it up to JND, which for us is 1.5 delta E 2000. And so that's really helpful when we're actually collecting data. You can also export the colorimetric data, the spectral data, and you can decide how often to sample a spectrum when you are looking at your data afterwards. So it's really helpful when you think about data sizes. It exports as text files, so you can import it into Excel, into Spectral Viewer, into Origin Lab if you're interested in plotting it for research purposes or publication. So it's quite flexible in terms of the data export. So I'm going to look at a couple of examples of things that we have done at MoMA that are kind of interesting study cases. I would say the first one is these beautiful prints, these woodcut prints by David Alfaro Siqueiros. And when we are coming up with the reports, we use PowerPoint. We find it very flexible in terms of the things that you can put in there. You can mark things up very nicely. So what we do in our PowerPoint reports, we usually put in an image of the works. We also indicate the areas where we collected that data. And when we start our day of measurements, I usually turn on the LED light source. I let it warm for about 10 minutes or so before taking my blue wool replicates. We do 3 replicates per colorant. So that includes both the blue wools and the objects that you're looking at for 10 minutes. With the blue wools, we would let it run the entirety of the 10 minutes, but with an object, as I mentioned earlier, we do have a stopping point of JND 1.5 delta E 2000, just because we are trying to avoid making any kind of visible change to the object as we're analyzing it. So this is what the window looks like once you collect the data. So the data can be collected as individual fading curves or color change curves. However, what's really nice about it, and something that we actually did lobby Fotonowy to include, was an analytics tab, to be able to average the data for several different collections. So this is kind of the tab that I look at when I'm looking at my data. So you can see I have my blue wool 1, 2, and 3. But then I also have some fading from the cover, which has been exposed to light more than the pink or orange woodcuts. And then you can see that the brighter orange corresponds to the orange woodcut to the left, and then the pink one is to the pink paper. And what's nice again is you can see that the data collection did stop before 1.5, or at 1.5, sorry, which is really helpful because it kind of allows us to, as JP and Kirsten already said, go do something else or work on data that's already been collected. So that kind of avoids making that kind of damage to the object. We look at our data qualitatively most often. So we're kind of giving it a qualitative measure. Is it close to blue wool 1? How close is it to blue wool 2? Is it tracking alongside or quite a bit below? So we use that kind of descriptive language in the way that we transmit the data to both curatorial and to conservators, but also to when we're thinking about putting it into the report as well in the language. We also investigate the delta L, A, B, and C to just kind of investigate a little bit more what is happening and kind of be able to describe again qualitatively the color change that is happening. Because quite often I don't like the term microfading. I think sometimes things are fading, but sometimes things are just changing. And so it's good to kind of qualify that change because quite often things do darken or they yellow. And it's good to qualify that change to understand, is it acceptable based on the data that we've collected? And just a shout out to Spectral Viewer, I do like it more than the Fotonowy software to look at spectral data in particular. I like how easy it is to look at. I also like that you can see the color spectrum underneath it. You can look at the data for the reflectance spectra in the Fotonowy software, but I do tend to prefer the Spectral Viewer just because it's just a more attractive final appearance, and it's really easy also to transmit that information to both curatorial and to conservators. What we do like about the Fotonowy as well is because the light source is calibrated, we can actually do some sort of extrapolation. Given that reciprocity holds, we understand that the reciprocity can break down at different illumination intensities and for different materials, but we can kind of do our best to guess, right, what the amount of color change that might occur after a certain amount of exhibition days at a certain illumination. And that, again, is very helpful when we're trying to make our decisions, because it might allow us to nuance a little bit the display strategies, either to think about lowering the light a little bit to kind of extend the lifetime of the exhibition or the exhibition period, or to feel comfortable, right? To say that, oh, it might only experience a certain amount that is below a visible threshold. And so we feel comfortable with showing it either for longer or at a higher intensities of light in the galleries. And like Kirsten, at times when we do look at multiples or a series, quite often we do end up scoring our works, which is helpful when we're thinking about rotation strategies, or we're thinking about which objects to display during an exhibition. So here's an example. We're looking at these beautiful hand-colored Warhol shoes series. And what I did in this instance is I actually did microfading on a brochure of the same colorants after we identified them. And I was able to score the colorants based on a blue wool equivalence scale. And then taking that scale, I actually looked at each print and calculated the area that each colorant occupies and multiplied it by its blue wool equivalence to come with a weighted blue wool equivalence for the entire print. And that's helpful when we're looking at multiples or a series of different prints that we understand the light sensitivity of, because then we are able to score them. And so if we're thinking about lending some objects, or we're thinking about putting some objects on display, we can hand this over to curatorial and allow them to make a selection that is informed by scientific data about the light sensitivity of these materials. And just quickly talk about maintenance. Earlier, as I was mentioning, we do a calibration. Fotonowy suggests that we do a calibration every 6 months. And what you do with that is that you're basically interrogating the output at different currents. And that creates a power configuration file from which the instrument can be able to look at the data photometrically and radiometrically. And so you can see here, we're looking for a linear behavior. If there's a huge deviation from linearity, then there's something wrong either with the spectrometer or there's something wrong with the LED light source. So far, everything seems to be okay on our end. And for maintenance, we actually just replaced our what they call a limit switch, or the contact sensor, because it broke. But they made a really beautiful video, and we were able to contract someone to come do just very simple soldering. So they're really great to communicate with, I have to say, and they're very responsive to our questions, which leads me to also looking at the online forum that they have. Unlike the other instrumentation, which is kind of assembled from different parts and you put it together yourself, this is a company that you can actually reach out to. And they do have a forum that is quite active, and people do post questions too. And then they respond quite quickly, and also allows different people, parts of the community to respond to as well. Thank you so much. If you have any questions, please feel free to email me. I'm happy to talk to you about the Fotonowy or just microfading in general.
Well, I want to thank all of our speakers again. We are running a little bit behind our proposed schedule due to the technical glitches and everyone's enthusiasm for their subject. So I think we're going to keep the panel discussion very short so that we can get right to questions from our participants. I'm just going to throw out one sort of broad question to all of you, right? Like, most of us have had experience with 1 or 2 models of MFT, and I can certainly say that I have things I both like and dislike about each model. Where do you see the next generation of evolution of this instrument going? Like, what would be the best of all three worlds in a future iteration of the instrument? You know, we want inexpensive, we want portable, we want super easy to use, but we also want automated, and we want customer support and an online help forum. What are your thoughts on this? Like, what are the things about your model that you want to see in future versions, and what could be better?
Okay. And we've looked at a couple of different alternatives which stay in place better, but which are inherently more difficult to clean. So, you know, if dust is going to get into your unit, those alternatives are actually more of a problem. So I think we're kind of stuck with that. Other than that, I think the other thing that I don't love about the Thomas unit is that the micrometer base that it sits on, the standard Thor Labs 1-inch movement micrometer base, is pretty heavy. And I'd love to get the weight of the whole unit down. But that said, I actually do really like this, putting it on a stand and putting the stand on the object where that can be tolerated by the object. And the weight of the micrometer base does actually help press all the fibers down, rather than you having a spot that's brushing a lot of fluff before it actually gets to something where it's taking a reading.
Okay, Kirsten, what are your thoughts since you've got the OG?
I've got the OG.
Yes,
I'm really
and with that
happy
broad
with it.
spectrum light source,
Yeah,
different from the LED based models.
yeah.
Is
I
that
mean,
a
that's what I'd
feature or a
like.
bug in your opinion?
I don't have any problems with it. It's, you know, it's the data that we're applying, and it's changed the dynamic of the way that we speak about light management at the organization. And that's really the best thing for me. So I love our setup. I would like to go to LED because, as Abed said, that's more realistic and a more realistic replica nowadays of gallery lighting in general. So that is a shift I would like to make. I'm not so bothered about going automated in terms of focus. I really like the manual focus. It helps me engage with the object and as part of the testing process. So that's not something I'm particularly worried about or bothered about. I like that element of usability of the kit. I like that sort of DIY element of it, and it helps me engage with the whole thing. But yeah, I think for us it's the shift to LED that we want to get to, and not having to use a manual shutter. So I've literally got like a filter on a lollipop stick to stop and start it. With the LED setup, that will change again. But it's easy to understand, it is easy to put together and move about. You just need that stable work surface. So I'm really quite happy. Maybe I'm just too easily pleased.
And Abed, you've already kind of addressed this a little bit, but did you want to add anything on this topic?
I would say, it's funny. I think for me, it's the black box of it all sometimes that does maybe me as I'm a scientist, I'm a tinkerer. Like I would like to see the main components and be able to replace things on my own or be able to adjust things but I think it just depends on the use, right? For us, again, it's less of a research grade thing and more of like answering a question and a need. So it serves that purpose very well, but quite often I'm interested, like, what will happen if we put this out in daylight, right? And we sometimes can't answer that question wholly because we don't have a UV light source, right? So I think it would be great to be able to do that. I think that, we were able to do that nicely with the Whitmore because you just remove the UV filter and you have UV, right? So I would say that element for me, it definitely, to Kirsten's point, I actually love the autofocus. I love all these like automated aspects of it, but I think it does make it more challenging when you want to modify things a little more to understand, other aspects of how something might behave under different kind of conditions.
Great. Well, why don't we switch over to questions from our participants? Vincent, do you want to
Sure.
pull up a few of
So we
them?
have a few questions here, and I'll just read out the first one. How are results documented, reviewed, and shared? I'm wondering if it would be possible or useful to share results in a similar way that AUDI test results are shared from different institutions. I know there is much variation in material, collection item, and display history, but it might be helpful to see results for pigments or artist work in that way. So does anyone want to start with a response?
I will say that's why I try as much as possible to publish any kind of results that I have that might be of general interest. That means works that other, like for example, when we did our work on Cezanne, I was like, there are so many Cezanne watercolors. And so we actually were able to identify the pigments and look at their light sensitivity, and that was of interest. So I think that's really helpful. But to Vincent's point, sometimes we have so much variability, and it has to be taken with a grain of salt, because at the end of the day, our objects have experienced, different lifetimes and different illumination.
Right. And the way a material fades reflects not just what it is, but what its previous light exposure history has been. In places, right? So even if you know exactly what it is, it may behave differently on your object than on another object with the same materials. So I don't know, this question has come up in some previous meetings, the question about sharing results, but it kind of defeats the purpose of MFT, which was to give you answers about your specific object rather than saying, well, this dye is known to fade at vaguely this rate, so we'll treat it like that. The whole point of this technique is to not have to do that kind of extrapolation, although your point that it could maybe save us all a lot of time, or make these results accessible to people who don't have the instrumentation or the time to implement it. It might be useful, but then not. I don't know. Anyone else want to weigh in? Or
so I think the point about you not starting with a pristine color is extremely important in a lot of the work that we do. Most of our material is collected having been used, so it's already had some exposure history. And the whole motivation for MFT was to try and get away from this rule of thumb approach and actually say, what is the specific problem for this item? So, for instance, that yellow quill I was showing, there's literature out there that suggests that most dyed quill is Blue Wall 2 equivalent, and clearly most of what we were seeing was actually much closer to Blue Wall 1, or above that. So, I don't think it's a horrible idea, because if you don't have the time or money to do MFT, it's obviously better to have some information than none. But I think it's difficult to understand how you would actually present this information in a way that was helpful, because the fading rate also depends on the light source that you use. So, are you thinking about fading in sunlight? Are you thinking about fading with LED-A or LED-B or whatever?
Yeah. If I could jump in and just pose a few questions for you, JP. So the first one is there some effect from the use of your remote flip shutter, specifically in terms of vibrations? So that's the first one.
That's why we moved away from the finger flip. It wasn't, the whole thing actually fixtures pretty well. So we weren't really worried about vibration from the finger flip itself. We did some testing on that and we just couldn't see it in the spectra. What we were worried was this bit where you unshutter is extremely tense making. Like there's a lot going on and you've got to manually move the shutter out. And what we were worried would happen would be someone would be sort of slightly more worried than they should be and actually poke the instrument rather than just flipping the shutter. So that's why we went to the manual, the photo cable release thing, so that everything can happen a good distance away from the object. And honestly, that's the thing that's most converted my MFT shy colleagues to doing it. They seem to really love pressing the photo release. It's just fun.
Another quick question for you, JP, is the Retroreflective kit from Jacob Thomas, is this available as a complete kit, or do you purchase the components individually?
You purchase the components individually, but we do have if someone wants it, we do have a complete list of the equipment to buy. And it's basically only two suppliers, Amazon and Thorlabs,
Okay.
plus the spectrometer and the so I thought that was going to be a problem, but actually it's super easy. You just put a big order in. And what I'm not sure if they're still doing it, but Thorlabs usually sends you a box of snacks in proportion to the amount that you bought.
Yeah.
So
JP,
you get
do
a
you have
really
that
decent
spreadsheet?
box of snacks.
Do you have that spreadsheet up on the discussion group resource page still? I know you were talking about
I actually just revised it.
Okay.
So I don't think we do, but we can put it in the MFT-IDG resources.
Sure.
Usually what happens is people email me for it and I just send it to them.
We're coming towards the end here. I just want to try to ask these three questions, so maybe we can try to keep our responses fairly tight. The first one is, do you use your instruments in subdued lighting conditions? So maybe let's ask Kirsten, how are you typically operating?
No, I just use it in the ambient conditions, and part of the software setup is that you record what the ambient conditions are, so the software knows what you're looking at.
Sure.
So you can use it in any room. I think everybody else is nodding, so yes.
I think if you do your light reference in the same conditions, then that kind of cancels it out. The second question is, how do you measure the focal spot size? I know for the Fotonowy, that's already given for each of the LEDs. So maybe JP?
So we use basically we turn the spot intensity down to a minimum and then focus the spot on a CCD board that's extracted from a Logitech C97 or something webcam. We know the pixel size on that, so we can measure it.
Okay.
And we typically do 5 replicates and then take an average once the standard deviation has reduced to a point where the measurement actually becomes believable.
Okay.
The lower tech approach is to use a piece of what's called sunprint paper, which is a paper impregnated with light-sensitive salts, and just expose that for a set period of time and measure the affected area.
And then the final question is, she was asking if any of these units are particularly user-friendly for us non-scientists out there. I think everyone is a scientist out there, but maybe not outwardly so. But maybe, Ben, do you want to address that one?
Sure. I mean, that was definitely for us a really main condition of what to do when we're kind of replacing our original Whitmore design. And we found the Fotonowy to be quite simple in terms of the data acquisition. I think it's always very helpful to have kind of a nuanced understanding of the data when you're doing the interpretation. However, I would say in terms of the data acquisition, I personally found the Fotonowy to be a lot easier. I've trained many conservators, interns, fellows, etc., on how to use it, and they pick it up quite quickly. And I will say I don't miss having to open the shutter manually. On on the Whitmore, that was the worst part because you have to do quite a bit of acrobatics to be able to turn it on and open it at the same time. So for me, I found it to be much simpler than using the Whitmore, but I think it depends on kind of how much you like to do.
Yeah. I mean, at the Getty, we have all the instruments except for Jacob's, and our Whitmore is probably still the workhorse. But I think there are different ways that people feel comfortable with the technique. So I think it's great to have these options. So, go ahead.
We've used the Fotonowy. If you want a walk-up benchtop unit like your Bruker FTIR or your PXRF or something, you definitely want a Fotonowy. It's like it's super easy to use. But I don't think that Thomas is significantly more difficult.
Yep.
And there is a cost difference too between the instruments, so something else to consider. Well, I think we will go to our final slide.
So we can just leave this up for a minute or two for anyone who's still here. If you want to grab links out of the chat, I want to remind you all that we would love to have any of you not already part of our online community to join us. And please share your feedback about both this webinar and ideas for future ones in the survey that will pop up when we close the meeting. We'll also be in touch with a follow-up email. And just reminders of some of our upcoming events here. We've got about 1 minute left. Any last thoughts from anyone? Thank you all for hanging in there with us, and we'll see you next time.
Yeah. Thanks, everybody.
Thanks again to everybody for their participation.